Practice set 10. Find the probability. You flip a coin and then roll a fair 6-sided die. The coin lands heads up and the die shows an even number. Well, think about the coin. Coin has 2 sides. Assuming it's a fair coin, one side is heads and one side is tails. And we want the probability that it lands heads up. The die, let me draw it out here. If you're not sure, take the time. It's better to take the time and get it right. And they were very clear that this is a fair die, so that means that it's not loaded, that every one of the sides is different. If you've heard of people who cheat at games, sometimes they use a loaded die where one side is a 6 and the rest of them are 5s or whatever. This is a fair die. So it has a 1 on one side, a 2, a 3, a 4, a 5, a 6. And this will always be the case for a fair die. And you want this one to land on an even number. So it could be the 2, the 4, or the 6. So on this coin, you have the probability of it landing heads up. That would be 1 heads out of 2 possibilities. And on the die, you want the probability of an even number. So there are 6 possibilities. 3 of them are even. So those are your individual probabilities. And you want to make them be an and. So 1/2 and 3/6. I can't say that word. That and tells me to multiply. 1 times 3 is 3. 2 times 6 is 12. That would also simplify down to 1/4. Or if you do 1 divided by 4, you will get 25 hundredths or 25%. You have a 25% chance of that happening. And I'm going to have to, maybe not, we can do it over here. Okay. Number 6, you roll a fair 6-sided die twice. The first roll shows a 5. And the second roll shows a 6. So I roll that fair die. There are 6 sides and only one of them is a 5. I roll it again. There are 6 sides and only one of them is a 6. 1 times 1 is 1. 6 times 6 is 36. Do 1 divided by 36 on your calculator. That is 0.027 repeating. So that is about a 2.7% chance. Not very good odds. Number 7. There are 8 shirts in your closet, 4 blue and 4 green. So I'm going to draw some dots for my shirts. 4 blue, 1, 2, 3, 4. 4 green, 1, 2, 3, 4. Total of 8. You randomly select one to wear on Monday and then a different one on Tuesday. So you don't put the dirty shirt back in the closet. What is the probability that you would wear blue shirts on both days? So you want to get a probability of a blue one on Monday, and then the probability of a blue one the next day. If you just close your eyes and pick one. And let me move this because I need space here. Let's pull the shirts over here and the problem right up here. All right. So on the first day, when no shirts are dirty, there are 8 of them in the closet. And how many of them are blue? 4. So on the first day, you have a 4 out of 8 chance of drawing a blue one. So let's say you do draw the blue one and you take it out and you wear it. You don't put it back in there because it's dirty. So on the second day, the probability of blue, there are only 7 shirts in the closet and only 3 of those are blue. And the word and means, yes, multiply. 12 on top, 56 on the bottom. That could be reduced by 4, I believe. No, yes, it can. 4 into 12 is 3. 4 into 56 is 14, so that would be lowest terms. If you do 3 divided by 14, you will get 0.214 and a bunch of other stuff. So I'm going to call that about 21% chance that that situation would happen. Pretty good chance. Not a great one, but not bad. And number 8. A basket contains 5 apples and 7 peaches. So you know what I'm going to do. 5 apples. 1, 2, 3, 4, 5. And then peaches. I'll use orange for that one. 2, 3, 4, 5, 6, 7 peaches. Total of how much fruit? 5 and 7 make 12, a dozen. You randomly select one piece of fruit and eat it. So you can't put it back in there if you ate it. Then you randomly select another piece of fruit. The piece of fruit is an apple, and the second piece is a peach. So the probability of an apple, and then the probability of a peach. So I close my eyes, I reach in that basket where there are 12 pieces, and I pull out an apple. There are 5 of them, so it could be any one of those 5. I'll let it be that one. I eat it, so I can't put it back. Then there are 11 pieces of fruit in the basket, and of those, 7 of them are peaches. And tells me to do what? You got it. I'm going to move this over so I have a little room. 7, 11. 7 5s are 35. 11 times 12 is 132. I'm going to go ahead and get my percent right here by doing 35 divided by 132. It's ugly. Most probabilities are. So about a 27% chance of that happening. And those are some very good probability questions.